And welcome everybody to the Daily Space Weather. Lots of stuff to cover today, talking about a solar flare watch, the growth of Sunspot 2833, and geomagnetic storms imminent and having had already happened here at the Smash News Network, least busted name in news. We've got some spectacular solar imagery as well. Here is a composite, 171 angstroms, as well as the LASCO C2 and C3 chronographs. Coronagraphs. I didn't say chronograph. Coronagraph. And that's actually not Earth-facing coronal mass ejecta there as far as we can tell. We don't see any Earth-facing coronal mass ejecta in the stereo A imagery. So solar activity is actually at a pretty low level here, despite a whole bunch of incoming stuff happening and geomagnetic storm conditions. Here's another composite. This is the magnetogram and 171 angstroms composite. And here's an absolutely spectacular close-up of Sunspot 2833. There is a bit of a disconnect there between the magnetometer and 171 angstroms rotation right at the end of the video. The fields did not stray that far from where the emission spectra are. Here's a solar system diagram. There's where things will be in 1 week. On the 23rd. Here's a star chart. If you're wondering what's going on in the sky, check in-the-sky.org, put in your location. We've drawn in the ecliptic, which has Saturn and Jupiter up there. And again, low levels of solar activity here. We see the 10.7 centimeter radio flux at 76 solar flux units. So quite low levels of solar activity, solar minimum like, maybe not quite as much as, maybe not as minimal as solar minimum, but here's this black line, that's the 1 year chart, and you can see 76 right about there in terms of the solar radio flux. And we've brought up the Space Weather Enthusiast dashboard here. We did already see geomagnetic storm conditions for a brief period. We'll show you the chart on that in a minute. The forecast is for continued periods of geomagnetic storm and geomagnetic unrest for the next about day and a half. So even some geomagnetic unrest forecasted here into June 18th by NOAA. Again, that's on the Space Weather Enthusiast dashboard. Let's take a look at global seismicity. We did see an earthquake initially reported at over a 6 magnitude. It's been downgraded. So about 4 hours from when we made the video, we saw a 6.0 reported at Seram, Indonesia. Let's check the rest of the list here. Again, it's been downgraded to a 5.8, but in any case, just checking out the list here. See some more quakes in California there. Nothing of a large magnitude. Deep quake at the Philippines at a 4.5 magnitude. Also one here in Peru. Northwestern South America, that is. Also some quakes there north of New Zealand in the Kermadec Trench. A 4.8 in the Mid-Atlantic Ridge. El Salvador saw a 4.1. Here's a 5.5 in the Mid-Atlantic Ridge. I mean the Mid-Indian Ridge. Right near the Indian-Antarctic plate boundary. So here's the largest quake of the past 24. There's a location of that. Downgraded from a 6.0 to a 5.8 here, right in the northern portion of the Banda Sea. And let's continue on here as we've got a lot of stuff to cover. Some volcano stuff going on in the news. We're going to even talk about induction into the U.S. power grid. We actually saw a brief power outage right here at the Smash Tower. So, Luatolo, as far as volcanoes go, it's one of the ones on the list. It's erupting and producing an 8,000-foot plume of ash over the Lesser Sunda Islands. Semeru on East Java, Indonesia, 13,000-foot ash plume there. And a third week of relative quiet passes on Kilauea, though earthquakes remain slightly elevated near the volcano summit, Upper East Rift, and nearby South Flank. No glow is visible. The Upper East Rift between Manaulu and Pu'u'o'o. Pu'u'o'o. Still within Hawaii Volcano National Park, refilling with magma. So perhaps about to see another uptick there at Kilauea. We'll see if some new real estate gets created in Hawaii. Fuego in Guatemala producing a 15,000-foot ash plume. Nevado del Ruiz in Colombia producing a 19,000-foot ash plume. 20,000-foot ash plume as Sangay in Ecuador explodes. Revenador back into active status today as it explodes as well. 15,000-foot ash plume over the other Ecuadorian active volcano. Sabancaya exploding over Peru, producing a 21,000-foot ash plume there. And while we're unable to detect whether or not Nevado State Chilean in central Chile is erupting, please do not pole vault the caldera. This public service message brought to you by smAsho because people are stupid. Some non-stupid people are our patrons. And thanks for donating, increasing the probability these videos will continue to exist and remain publicly visible and free for all to view thanks to our patrons. Consider becoming a patron at patreon.com/smashamash. You get all kinds of perks that I won't even elaborate on in this video. Thanks again, patrons. No major solar flares going on in the past 24 or even 36 hours, although it looks like there could be one happening as we make the video. No spikes in the proton flux. No coronal mass ejections headed Earth's way. At least, apparently not. I did pour through the stereo A imagery, more on that in a minute. The GOES magnetometer is looking spiky here and sawtoothed as there is a bunch of plasma already striking the geospace from a coronal hole wind stream. And it got up to about 50 protons per cubic centimeter in terms of its density. We'll show you that in a moment. First, the top view ecliptic plane field plot looking at the polarity of the plasma. It's the plasma polarity. And you can see the delay happening here on this North Pole current sheet arrival. An indication that Sunspot 2833 is either weakening or perhaps the south solar polar field is strengthening. But in any case, there you go. There's the data. It's showing you red for South Pole polarity and green for North Pole polarity. Anyway, there's the latest image. The North Pole current sheet is still at least a day away, I would have to say. Keep in mind the magnetic environment can change with no warning. Next, the line of sight ecliptic plane field plot. It's basically the same data. We won't spend a lot of time on it as we've got lots of content to make today. Line of sight coronal hole plot showing us the coronal hole that's providing the protons that are striking the geospace now. It's this coronal hole down here, the South Pole oriented one. There is a bit of North Pole activity rotating in here. And leave us a comment if you think there's a relationship between sunspots and coronal holes. Here's the latest image from El Teide, Spain. Let's actually bring that up again here. There we go. There's the latest image from El Teide, Spain. It is quite timely. And we see a possibility of some additional umbra growing here northwest of the main umbra on Sunspot 2833. More on that later. And just a little bit on the stereo A imagery. The animations are still not working here. If you click on this, it will sit there loading forever. However, if you go to the gallery, you can actually look at quite a lot of data here. There we are going back to 615. And if you bring up 615, that'll bring you back to 614 and so on. Again, the coronal mass ejections we've been seeing are on the opposite side of the sun here, not Earth-facing coronal mass ejections. Although I would keep an eye on the current situation because we could see some. So there are the current images, and with the current state of affairs on the Earth-facing portion of the solar disk, we could indeed see some coronal mass ejections headed our way. And stereo A for you new viewers is located here at Lagrangian point 5. It chases the Earth, orbitally speaking, but it sees space weather ahead of the Earth, which is why it's called stereo A. Stereo B is located out there at Lagrangian point 4. And I would invite all of our viewers to check out our own website, smashamash.com. Smashamash.org will redirect you. If you click on SmAsho merch, you'll find our merch shop. And we've taken a 5% hit on all of our profits through the month of June. So everything at our shop is on sale. Cheers. 7 designs available there. You can link to it directly from the homepage at smashamash.com. So you can see we did get into geomagnetic unrest conditions here in the approximately 6 hours before midnight universal time. And we do see some induction in the U.S. power grid, even going on to this moment, probably. We'll show you the empirical data on that in a moment. First, a geospace magnetosphere movie. You're looking at 4 hours of data here, hopefully, if all goes well. And you're looking at magnetohydrodynamic pressure, which is increased. So we saw the signature of a coronal hole wind stream in all of its perfection, where you see the solar wind density increase and then drop off as the solar wind velocity increases. And we decided to show you this before showing you the real-time solar wind data today, to show you these pulses coming in. So you can see these pulses here, right in this portion, where there's different magnetohydrodynamic pressure showing up, and that will indeed show up as pulses in the velocity. So here's the real-time solar wind data. And you can see these little changes going on with the velocity, also shifts in the phi angle. We also do see a relatively consistent negative BZ happening here, especially at the beginning. So that has subsided a little bit, and that's part of the reason why we saw geomagnetic storm conditions. Now that that's subsiding, that's chilling out a little bit, but we still see a significantly elevated solar wind speed here. So 573 kilometers per second, solar wind density now down to 8.26. And again, we saw the solar wind density make it all the way up to nearly 50 protons per cubic centimeter here before dropping off this standard signature of a coronal hole wind stream. Next, ground magnetic perturbations. Geospace delta B changes to the Earth's own B field. We showed you the sun's B field. Now it's time to look at the Earth's B field. And we do see some significant magnetic activity going on. Some associated with the South Geomagnetic Pole, some associated with this area here south of South America, also one of the North Geomagnetic Poles, the Canadian one, seeing more perturbations than the Siberian one in that run. I'm going to let it run a second time here, since we've got significant geospace delta B changes to Earth's B field showing up in nanotesla. So keep in mind, this is just change in the field, folks, not real field measurements. It is Space Weather Modeling Framework model. And like the geospace magnetosphere movie, it's 4 hours of data. And you can see those Pacific Ocean pulses once again. By the way, we do regularly stream live to Twitch. If you're not familiar with that, twitch.tv/smashamash. Thanks to our followers over there. And thanks to our new YouTube viewers. Please tell your friends and your foes about the channel. And if you're new to the channel, press like and subscribe. Press that share button, share on your social media, and let us know in the comments what your favorite social media is. We're probably already there. We're also on BitChute, and we are counting down to the solstice. We will be streaming live for the solstice. The June solstice occurs at 11:32 and 9 seconds. That's PM, Eastern Daylight Time. We'll be streaming live. Join us. We'll be on Twitch and YouTube, possibly even on Facebook. We'll be doing a live stream this afternoon. We might even bring up crayfish. We might even bring up orcas. Who knows what could happen in our new segment, our Wednesday afternoon stream at 2 p.m. Eastern Daylight Time. So check us out for that. And our cosmology segment will be a separate video today, so make sure you check that out if you've only watched the daily space weather. Next, looking at electron flux around planet Earth. And indeed, we do see some charging hazards. We see a graphic missing, so we'll just show you this one. And we see charging hazards in the standard spot over Central America, Northern South America, the Caribbean, and the Central Pacific. And that'll be moving to the west, obviously, as the planet rotates. Here's the one-year chart of the relativistic electrons. Here's me vanishing. And there's the 3-day chart. And we're still seeing surprisingly low levels of electron flux. My electron flux increase has been canceled until this coronal hole wind stream subsides. So I would say we're not going to see this increase as forecasted here, expecting it to stay flat over the next day and a half. As a coronal hole wind stream is like a proton light event. I'll just leave it at that. Next, looking at the total electron content forecast to see massive anomalies down here in the southern Atlantic Ocean and southern Indian Ocean. So I'm going to rock that back so you can see that again. Right in here, And I would note the time and date stamps. Some serious anomalies here associated with the South Polar region. And we have documented similar anomalies to that before. Some major blobs of electrons totally out of place there. Not in the normal spot. So normally they stay largely constrained to the Van Allen belts. Here's a diagram of that. And distances are shown here in miles. And next we're going to show you the ionosphere. At about 300 kilometers of altitude, we've got a layer of the atmosphere known as the ionosphere. It's where there's a lot of vibration and chemical reactions going on. It is largely the bridge between space and Earth. And so we show a full day of it. And we're seeing significant anomalies here in the northern hemisphere once again. So some oddly high vibrational areas here over places like North America. And we don't typically see this associated with geomagnetic storms. So this is sort of new ground here. We actually featured some ionospheric anomalies on yesterday's thumbnail. And there you can see some going on. Surprisingly far northward shifting vibrational frequencies going on there. And each color blob here represents 1 megahertz or a million vibrations per second. So even there, the latest image coming in at 8:30 Universal Time looking a little bit anomalous. And again, the ionosphere is located at about 300 kilometers of altitude, at least the F layer of it. The D layer is down at under 100 kilometers of altitude. The ionosphere. And next we're looking at induction into the U.S. power grid. So this is the empirical 1-minute 3D model of the U.S. power grid, at least the non-Texan portion of it. And you're looking at millivolts per kilometer, literally the data. And again, we actually had a transformer explode here. My friend was outside and apparently saw it happen. And you can see significant induction here, nothing too extreme. And of course, there was a lot more of it back here when we were in geomagnetic storm conditions. And if you're wondering where we're located right about here in Lehigh Valley, Pennsylvania, just west of New Jersey. We do see some power outages. Indeed, about 13,000 custies out of power in California, and about 13,000 out in Texas, and about 14,000 out in California. And we're going to do a meteorology segment today as well. Make sure you check that out if you haven't. It'll be a separate video here at the Smash News Network. Least busted, name and news. And so we just did our meteorology segment. Let's get through our bonus features and get the video out. Here's some hydrogen alpha imagery from Udaipur, India. And again, we can see large filaments all around the limb of the sun. You can see filaments up here, filaments, filaments, filaments. The likelihood of a coronal mass ejection is significantly high. Despite this sunspot not being too complex, we do see some activity. It looks like it may be growing some new umbrae. Let's take a look. First, the thematic imagery from the GOES 16. And I've lost control. And I've regained control. So I like this thematic imagery here. It shows you lots of features. It may be a little bit confusing to our new viewers. You can check it out yourself at the GOES Solar Ultraviolet Imager, or SUVI. So here are the latest images of Sunspot 2833, and you can see it may be growing some new umbrae there. So there's the high-res imagery. And right up here, there's some activity possibly growing in that area. It does not appear to be a beta-class sunspot yet, but don't be surprised to see it turn into one. And if it does turn into one, the likelihood of coronal mass ejections and solar flares is much higher. Here's some close-ups of the closest star to close things out. This is a composite 131 and 94 angstroms. Fantastic imagery. Here's another composite. This is a full disk view in 211 and 193 angstroms. By the way, all four of those wavelengths are ionized iron. Iron has a lot of ionized states. Here's another close-up. This is a composite of 171 angstroms and 304. That's ionized iron and ionized helium in the same view. Fantastic, spectacular imagery here from the Solar Dynamics Observatory. And we'll close out the video with this full disk view in those same wavelengths. So thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, don't drink, and if you do, don't drive. Don't forget to press like and subscribe if you enjoy the content. We'll see you next time at the Daily Space Weather. May that solar wind be at your back. And also don't forget to check out our live stream later this afternoon at 2 p.m. Eastern Time or so. We'll be streaming live on YouTube. It'll be a YouTube exclusive. From the Smash News Network, least busted name in news.